Thanks, everyone. So hi, and thank you for having me here. So just 2 seconds. Yeah. So today I would like to talk about implicit parameters. Implicits is probably one of the most feared features of the Scala programming language, and I think for good reasons. First, implicit can be used in many different places to do completely different things, which makes it difficult to understand what is going on. Additionally, if you come from another mainstream programming language, they don't really have something similar to implicits. So we don't really have any design patterns or book to know how to use them properly. And we quite often misuse them. So really the goal of this presentation is really to answer this question. When should we define a parameter as implicit and when we shouldn't, most importantly? Does it make sense? Cool. So first, I would like to start to look at how implicit works. So just to look at the scaffolding, and then we'll go through 2 design patterns that I think kind of make sense to use implicit parameters. So let's go through this use case where we have a blog post, where a blog post has an author, which is a user ID, a title, and a content. So, and let's say that we have this method, create empty blog post, that takes a title explicitly and the author, the requester ID, implicitly. Right now, I'm not going to explain, why did I make this choice? We're going to discuss it a bit later. For now, I just want to kind of review how do we even work with such a method. And as you can see, this method actually create a blog post by specifying the author, the title, and no content. So how do we even call such a method? How do we work with it? Well, first of all, we can pass the argument explicitly. We can always do this. We can kind of ignore that there is an implicit. Now, we can do it, but in practice, we never use it this way. It's not really idiomatic. In practice, when you have implicit, we don't specify the arguments, and we let the compiler pass the arguments for us. So in a sense, it's like dependency injection made by the compiler. But how does the compiler knows which argument to pass? The compiler kind of maintains a map from type to value. This is not really how it's done in practice, but it's a good way to think about it. And this map, when I say type to value, is you think about it like you say you have the key int, and the value is a value of the type of the. So for example, here we have int 5, string empty string, and user ID John1234. So when we call our method create empty blog post, what happens at compile time, the compiler looks up this map and says, oh, what is at the key user ID? It's user ID John1234, and it puts it there. So at the end, once your program is compiled, it's exactly the same as if you had put it manually. It's no difference. It's just syntax, just dependency injection, nothing else. But the next question is, what happens if you don't have a user ID in the map? So what happens if we're in a case like that? Then when the compiler looks up the value, it's not there, and it triggers a compile time error that says could not find implicit value for parameter requester ID. Next question, how do we put things inside of this map? How do we tell the compiler, I want John1234 to be my implicit value? This is where we need to use the implicit keyword, but this time before a value. So here we say implicit val requester ID, and this is a way to tell the compiler, please add an entry into my implicit map and say that user John1234 is the implicit within this step. And now it works. Something very important to note is that these implicits are not globally available. It's not like a global variable. It's actually scoped. So for example, let's say that we have a test where here it's 2 unit tests for create empty blog post, and this implicit value is only defined within the first unit test. This means that the first test compiles, but the second doesn't, because essentially here, when I call create empty blog post, it cannot access the implicit value. It's not visible. And if you want to know the rule of thumb about how visibility works, essentially is if you were able to insert here your requester ID without any special import, and if you could pass it explicitly without any import, then the compiler can see it. If you need a pass, then the compiler cannot. So how do we fix this? Well, it's very simple. We just move the implicit outside of the test, and now it's accessible for both unit tests. Does it make sense? Cool. So if we summarize what we've seen so far, first, the compiler keeps track of all the implicit available within a scope. Second, at compile time, the compiler injects all the implicit parameters for us. So it's a dependency injection part. And if an implicit is missing, we get a compile time error. There is actually a fourth, like a second error scenario, is if we have two or more implicits with the same type available, then the compiler will produce a different error that will say ambiguous implicit error. And it makes sense because, the compiler needs to inject the value for us. And if he has two or more values, it just doesn't know which one to choose. It has to be automatic, so it must be unique. So this leads to this rule about implicit is that within a scope, there must be only one implicit value per type. That's very important. Cool. So now we've seen how it works. Let's look at patterns to use implicit parameters, where it makes sense. So the first one, I call it the environment pattern. And essentially, the environment pattern separate arguments like parameters in two kinds, like the normal kind of parameters that changes every time we call the function, and the environment patterns, which are kind of static within a given context. So I know it's quite abstract, but if you look in practice, it will make sense. So let's say, we work in an application that manages our blog post. And this application, the only interface it has with the external world, it's an HTTP service, which has a couple of methods, one to create a blog post, one to update a blog post, one to delete a blog post. So what happened in the implementation is that the first thing we do in this HTTP service is first we authenticate the user. We just check, do they have the right to perform this operation? And at the end, we get a user ID and we mark it as implicit. So we really say, this user ID is the implicit, is the user ID within my workflow. And then somehow we have, we delegate the implementation to an API, which, create an empty blog post, save it to a database, and so on. But like the important point is this, is like, if you look at the pattern, is that at the entry point of our application, we mark the user ID as implicit. And then whenever we use it, it's passed around implicitly by the compiler. And the benefit of this is that first we have less boilerplate because, because within our application, everything is driven by an HTTP request. We know that we always have someone who made the request. So it will be a bit annoying to pass this user ID around all the time. It's nice to, you still need to define it, but you don't have to, pollute your API with this. But it's not the most important point. I would say the most important point is the fact that we have the compilers that guarantee the uniqueness of this requester ID. In a sense, like, it's very difficult to mess around. Like, and, once it's defined at the beginning, you can't really define another user ID implicitly, otherwise it will be an ambiguous implicit. So you have the compilers that guarantee the fact that there will be only one user ID, only one requester ID within this context, which is kind of nice. So let's go through another example to really understand this pattern. Let's say that we want to extend our blog post and we want to store the time at which it was created. So it's very simple. We could say, okay, let's call the method instant.now that will give you the time it is when the method is called. It's nice, but it makes our program difficult to test because instant.now is non-deterministic. It will give you different results all the time you call it, which means if you want to write some kind of test, you won't know exactly what was the timestamp. Now, there are workarounds. You can use some kind of mocking framework that cache the call to instant.now. You can kind of ignore this field, but all these methods are not super satisfactory. I would say a better approach would be to define like a trait, like an interface clock that give you access to this method now. And then you have different implementation. You have one that says this is a real clock, the one we use in production, and one that is like the static clock that you want to use for your test, something that will give you always the same kind of result. And how do we change our API? Essentially, create empty blog post now will take two implicit parameters, the requester ID that we've seen before, and the clock. And when you do clock.now instead of instant.now. And in the main of your application, you're going to say, within my production code, I want to use a real clock. And within my test, I want to use a static clock. And if you've been using Scala for some time and you use futures, you're already familiar with this pattern because this is exactly how execution contexts work. Like an execution context is like a thread pool. And essentially quite often what we do is that in the main of our application, we say, oh, I want to use a global execution context everywhere. And maybe within a test file, we want to say, oh, I want to use a single thread. So really the environment parameters idea is that they are static. These parameters are static in a given context. They only change when you change the context. And what's a context? It can be whatever you want, but I found that the two that works very well is per request. So you say like every time I receive a request, it's a new context. When the request is done, it closes it. Or the prod versus test request, which I think are easy to understand, easy to explain. I find that it works well. Now, if you want to use this pattern, I have a few pieces of advice for you. First, you should use precise type in your implicit parameters. So don't use int, boolean, string, because they are meaningless. You don't really know what it is. Because, because of implicit, it is to be only one value per type. Like if you use int, for example, maybe in one method will be the size of a queue, and another time will be a port number. So if you really want to pass these arguments implicitly, which I'm not sure it makes sense, but if you want to, then create a wrapper type or new type. You will say, like, let's say, a case class port number that will wrap an int. In that sense, the example I had with the user ID may not have been so great because you may have a method that say like share blog post that says, given a blog post and the user with whom I want to share the blog post, and you have the person who requested the sharing. And I find it a bit confusing to have one user ID that is passed implicitly, one that is passed explicitly. I mean, the compiler will be fine with it, but you have the chance that you may put it in the wrong place. And in that sense, I would say a safer way to deal with this is to create a wrapper type, again, like requester IDs that wrap the user ID. And then now you say that the requester ID is only used to store the user IDs that created the request. So it's a simple technique, but it helps in practice. Second piece of advice is use clear and simple context, because we know that the value only changes when we change context. So it has to be clear when this happens. And I found in practice like this per request or production versus test, like easy to understand, easy to explain. If you want to use something too fancy, it may not be the right choice. Cool. So really, this is the only, if there is one thing you need to remember about this presentation is the golden rule for implicit. The value of an implicit parameter must be obvious. And it must be obvious for you, but also everyone in your team. So if at some point you're like thinking, what is the value that is passed by the compiler here? You check your imports, you're like, it's probably you're doing something wrong. Just pass the argument explicitly. It's so much easier. Cool. So let's look at the second pattern that I think where implicit makes sense. And it's called the type class pattern. So in the type class pattern, the idea here is that we kind of want to create a method, like let's say we write an HTTP framework, and we want to have a method, OK, that takes various kind of arguments. And essentially what is it going to do is it's going to create an HTTP response with status 200, and it's going to serialize the input into JSON. Okay? So how do we implement such a method? Well, we can say, OK is a method that takes a type parameter A, going to return an HTTP response with 200, and it's going to serialize it to JSON. But the question is, how do we serialize, an arbitrary value to JSON? Can you serialize everything to JSON? Now, it's a bit of a contrived example, but let's say, imagine if you were going to try to serialize like a function. How do you serialize a function? It doesn't really make sense. A more realistic example will say, like, you have your application with your business model, and your business model is kind of private to your application. You don't necessarily want to expose it to the external world. So you may have like data DTO to like for your JSON API, maybe DTO for your database, and you only want to serialize your DTO to JSON, but your business model, you don't want to serialize it to JSON because this is something that may change very often, and you don't want to break your API because you change your business logic. So you really want to be able to control, say, I want to serialize some stuff to JSON, but if something is not serializable to JSON, ideally, I would like to get a compile time error. So this is the use case. So how do we fix this? Well, we could create a trait, a JSON encoder that takes a type parameter. So this is generally called a type class. And this type class, this trait, either like takes an A and produces JSON. And what we can do is that then change the API or OK method so that it takes an A, a value to serialize, and the serializer. It works, but it's ugly. You know, now when you call your method OK, you need to pass the serializer manually. And it doesn't make much sense because in practice, we mostly have one way to serialize one type to JSON. So how can we improve? Well, this is where we can use implicits, right? We can say, let the compiler pass the encoder for me. So we define the encoder as an implicit parameters, and we define the specific encoder for user and list of user ID implicitly. And now we get back this nice API where we don't need to specify the encoder anymore. So it's nice. But the problem is that we need to define the encoder within our HTTP routes, which is a pain. You know, you don't really want to duplicate your encoder everywhere. So what could we do? Well, we could define a custom object where we put all our encoders there and then import it somehow in our HTTP route. It works. But it's annoying to have to do this because first you need to remember what is the import. I never remember such a thing. And you need to put all your encoder in the same file, which is also not great. And this is why in Scala, there is a special rule for implicit search. So we have seen so far that your implicit, the compiler can find them within the scope of your function. But there is another rule. It says that when you search for a JSON encoder of user, the compiler will also search for it in the companion object of user. So because user is the argument here, it will search the companion object of user. So it means that if you define your JSON encoder in the companion object of user, it will somehow make it globally available. Every time you look for a JSON encoder of user, the compiler will look for it there, which is nice. Now you don't need any custom imports. It's all good. Yes, but it doesn't work for everything, right? What about a list of user IDs? So the compiler will check for a JSON encoder of list of user ID in the list companion object. But do you have a JSON encoder of list in the list companion object? No, because it's part of the Scala standard library and there is no JSON encoder there. And you're not going to submit a pull request to the Scala compiler to say, can you please add an encoder for my case class? Like, not going to work. So here, that's why there is a second rule for your implicit search that says that you can also search in the companion object of your type class. So for example, if you define an implicit in the JSON encoder companion object, then it will also be globally visible. So it's nice. So really the rule is like if it's a class that you control, it's inside of your code base, then do it in your companion object. If it's a class that you don't control because it's part of the Scala standard library or something else, you put it in the companion object of the type class. But the next issue here that we have is that how do we define a JSON encoder for list? Because a list of what? We don't really want to duplicate it for every single type of list. So here is where we can do something else that's a bit more fancy. It's called like type class derivation. It means that instead of make it a val, we make it a def, and we say like, let's create a JSON encoder for a list of A. But we still don't really want to do this because it would mean that you will be able to create a JSON encoder for a list of everything. And we've discussed before that everything is not serializable to JSON. So we kind of would like to constrain it in a way to say, I want to define a JSON encoder for list for every single element that are itself serializable to JSON. So how do you express this condition only for the stuff that are itself serializable to JSON? And this is where it starts to be complicated because you have this kind of like nested implicit where you say you have an implicit of an implicit. So the first implicit here means like, let's create a new JSON encoder and make it available. And this one is a conditional that says, let's only do it for items that are itself encodable to JSON. So it's complex, it takes time to get used to it, but it's possible and it's quite powerful. So just to summarize, what is going on here for the compiler point of view. When you search for a JSON encoder of list of user ID, The compiler will first search into the current scope. It can't find it. Then it searches the companion object of list, can't find it. Then it searches the companion object of JSON encoder. It says, yeah, maybe it's possible if the user ID is serializable to JSON. And then it searches the companion object of user ID and it says, oh, yeah, there is one actually. And it just all works out. But you have this like kind of pipeline of things that the compiler way is looking for. Does it make sense? Cool. So now let's summarize the thing. So we have our method, OK, that takes this implicit encoder. Now we can call it with almost everything that is serializable to JSON, and we don't need any custom import. It just works fine. And if we call it with something that is not serializable to JSON, we get a compile time error. So it's exactly what we wanted. This is a bit of a mouthful when you see this definition. That's why there is an alternative syntax in Scala where you can say a column JSON encoder. And it's the same as this. It's just a way to say, I want my A to have an instance of the type class JSON encoder. Once you're familiar with this pattern, it makes sense. But at the beginning, you can use this. It's completely fine as well. It's a matter of style. And to summarize, when you have a case class that you own, this is part of your application. You define the implicit in the companion object of your class. If it's a type that you don't control, like an int, a string, a local date, you define it in the companion object of the type class. That's the pattern generally. You have fancy stuff like this type class derivation. I'm going to skip it, but essentially the main idea is that you can potentially derive stuff, like create stuff. For example, you can say, if I have a case class of user and the user ID, you know how to serialize it to JSON, you know how to serialize the mail to JSON, and you can tell the compiler, yeah, figure it out for me, like create the thing for me. There are libraries like Shapeless and Magnolia that do this in Scala 2. In Scala 3, it's amazing. We have this derives keyword. So it's part of the language now. And we can say like case class user and derive the JSON encoder. And we don't need to deal with this implicit anymore. It's all done automatically and it's very nice. Now, a few pieces of advice if you want to work with this pattern. First, don't define your instances of your type class in custom objects. Why? Because then you have, when you see code like this, OK of user, then the behavior of this line depends on your import. And this may be like, hundreds of lines above, and nobody checks the import anyway. So it makes your code difficult to understand. If you really have a use case where you have different encoding for the same class, then just pass the thing explicitly. There's nothing wrong with that. Meaning that you can define your encoder as a normal value and pass it like this. That's completely fine. And it's more verbose, but everyone will understand what is going on. And I think this is the most important point. Again, this golden rule about implicit, that the value of implicit parameter must be obvious. If it's not obvious, pass it explicitly. Another counterexample, like if you look at the Scala standard library, there is a type class called ordering. And this type class allows you to compare values to one another. Say, is it bigger? Is it lower? Is it the same? It's a type class because if you look at the API for like the collection, you pass this ordering implicitly. But in my opinion, it's a mistake. Why? Because when you have code like this, like list819.sorted, what does it give you? Do you know? Do you get like 189? Do you get 981? Do you get something else? 189, but I never remember. I've been doing this for 10 years. I never remember. And there is no reason. Why is it like this? And if you want to do it the other way around, I mean, you could potentially reverse the list, but it's a bit less efficient. What you can do is, again, define a custom implicit that you do it this way. But again, you have the same problem, is that you have this line of code here that depend on this implicit, and there is potentially many lines in between. So you're not really sure what is going on. I would argue that it will be much better to have code like that, where the ordering needs to be passed explicitly, and we'll say list 819 sorted, and you say ascending, sorted, descending. Sure, it's more verbose, but it's clear. And this is what matters. Cool. Again, remember one thing, implicit must be obvious. Okay, so I may have like a minute or 30 seconds. I just would like to quickly talk about Scala Jobs. So Scala Jobs is a job board and a recruitment agency for Scala developers. So we were disappointed about like the general tech recruiters, and we are trying to fix this or improve this. So because this job board is dedicated for Scala developers, we are trying to make it like convenient for you to put the stuff that you're interested in. So for example, the tags about the specific libraries that are used, we push our clients to put like public salaries, to put stuff like remote, the things that really we care about. And we also have a recruitment agency. So we are really headhunting, talking to customers, trying to understand like people, what you're looking for. Because I think quite often recruiters, they have no clue what they're recruiting for. And I think this is where having a developers to be more like your agent than something else, that will be great. So if you're looking for a job, or if you want to hire people, please contact us like at scalajobs.com. We also have the same with Rust. So if you're interested, like check it out, or talk to me, or Alex or Archie, which are here today. So thanks everyone. And if you have any questions, I'm not sure we have time, but we can talk about it outside.